Dear children, hope that all of you are safe and comfort at your home. Today, we are going to discuss some important properties of inverse trigonometric functions. Let us start with some simple problems. Please. The first question is, find the principal value of sine inverse minus 1 by 2. Let us assume that sine inverse minus 1 by 2 equal to some x. So let sine inverse minus 1 by 2 equal to x. But we know that the range of sine inverse is closed interval minus pi by 2, pi by 2. That is, the range of sine inverse here in the first quadrant and the fourth quadrant. You can see here, if this line is subtending an angle x with about x-axis in the positive direction of x-axis, then the coordinate of this point will be cos x sin x. We have studied in class 11. So this OD will be the cos x and this perpendicular line will be the sin x. Now minus x, that is in the clockwise direction, the same measurement in clockwise direction, that is minus x. So automatically the coordinates of this point will become, because it is a mirror image about y equal to x. So this coordinate of this point become cos of minus x, sin of minus x. Now this cos of minus x is again this OD, and sine of minus x is this line. So this is in the negative direction of y-axis. So this is the negative. So sine of minus x is actually the negative of this line segment, this length. It means that sine of minus x is a minus sine x. We have taken that information here. Now, so sine inverse minus 1 by 2 equal to x implies sine x is equal to minus 1 by 2. That is, sin x is equal to minus 1 by 2. Sin pi by 6 is 1 by 2. So I am taking instead of 1 by 2 sin pi by 6. Now, just we have explained here by the same condition, sin x is equal to minus sin pi by 6 implies sin x is equal to sin of minus pi by 6. So sin x is equal to sin of minus pi by 6. So x is equal to minus pi by 6. Because sin inverse, the range is between minus pi by 2 and plus pi by 2 in the closed interval, minus pi by 2 and plus pi by 2. So we got that answer. That's a simple question. Now let us think about another question. Find the principal value of sin inverse cos of sin inverse root 3 by 2. Now what is sin inverse root 3 by 2? It is pi by 3. So this can be written as sin inverse cos of sin inverse root 3 by 2 equal to sin inverse cos, and this is a root 3 by 2. So sin inverse root 3 by 2, and that is pi by 3. So it is a sin inverse cos pi by 3. Now sin inverse cos pi by 3. Cos pi by 3 is a 1 by 2. So sin inverse 1 by 2. Now sin inverse 1 by 2 is pi by 6. So answer is pi by 6. It's a very simple question. Let us discuss this question. Find the principal value of tan inverse root 3 minus sec inverse minus 2. It is a CBSE board exam question for which it carries a 2 mark CBSE board exam question. So this is asked in CBSE 2012. 2012. At that time it was for 1 mark only, but at present the pattern changes, so there is a possibility of getting 2 marks for this particular question. Let us see what is this. How to solve this one? So tan inverse root 3 minus sec inverse minus 2. What is the range of sec inverse? A range of sec inverse is 0 to pi by 2, half open interval, 0 to pi by 2, union pi by 2 to pi. That is, from the closed interval 0 to pi, the point pi by 2 is excluded. Now, sec inverse minus 2 we have to get, because tan inverse root 3 we know that. Now, root 3 is tan pi by 3. So, this can be written as tan inverse tan pi by 3 minus sec inverse. Agreed. Now, sec, there is minus 2. See, sec inverse ranges from 0 to pi by 2. Union pi by 2 to pi. So, sec is negative in this pi by 2 to pi. That's in the second quadrant. So, there I am writing that sec of pi minus pi by 3, because sec of pi minus pi by 3 is minus sec pi by 3, minus sec pi by 3 is minus 2. So, this minus 2 can be written as sec of pi minus pi by 3. We have studied in class 11. So, we got now tan inverse tan pi by 3 minus sec inverse sec of pi minus pi by 3. We know that tan inverse of tan of x is x only. So, tan inverse tan pi by 3 is pi by 3. Sec inverse of sec of pi minus pi by 3 is pi minus pi by 3. That is pi by 3 minus pi minus pi by 3. And the answer is minus pi by 3. Okay, so let us think about the properties now. Just simple questions, the initial stage I have discussed. Now let us study the properties of inverse trigonometry functions. Then we have to solve some very good questions. Please check. So, properties of inverse trigonometry functions. The first property number 1. Sin inverse 1 by x equal to cosec inverse of x. Where x greater than or equal to 1 or x less than or equal to minus 1. That is the range of cosec inverses. X greater than or equal to 1 or x less than or equal to minus 1. In this property 1, there are a set of 3 properties. Cos inverse 1 by x is equal to sec inverse x. Where x greater than or equal to 1 or x less than or equal to minus 1. Otherwise, we can say that modulus of x greater than or equal to 1. Now, the third one is tan inverse 1 by x is equal to cot inverse x. These are the 3 important properties in the first property. That's 3 important results in the first property. We can prove this by the trigonometric result, by using the trigonometric result. I shall prove for 1, and the remaining 2 I am giving to you as homework. So, proof for the first one, sin inverse 1 by x is equal to cosec inverse of x, where x greater than or equal to 1 or x less than or equal to minus 1. What we have to take? Let us take cosec inverse of x is equal to some y. Cosec inverse of x is equal to y. But we know that f inverse of x is equal to y implies x is equal to f of y. Same way, cosec inverse of x is equal to y implies x is equal to cosec y. So cosec y is equal to x. That is, x is equal to cosec y. Now let us take the reciprocal. So 1 by x will be 1 by cosec y. What is 1 by cosec y? 1 by cosec y is sin y. So 1 by x can be written as sin y. Now, if x is equal to f of y, f inverse of x is equal to y. Same way, 1 by x is equal to sin y implies sin inverse 1 by x is equal to y. But what is y? Y is cosec inverse x. So we got the result. Sin inverse 1 by x is equal to cosec inverse of x. I think it is clear. The proof is clear. It is a very simple proof. For the remaining two also, you proceed the same way. But all these trigonometric, inverse trigonometric results can be verified with the help of graph also. So, here I am going to discuss the graphical or geometrical verification of this result. Sin inverse 1 by x is equal to cosec inverse of x. Let us see. That is geometrical verification or graphical verification. You can see in GeoGebra. See, dear children, all the results of inverse trigonometric functions can be proved with the help of trigonometrical functions. In the previous case also we have proved in the trigonometrical cases. Just listen this here. See, this is the graph of, this is the graph of cosec x. This is the graph of cosec x. Now, from here we have find the inverse by restricting its domain. When the domain is restricted, we will get the graph in this way. This was the graph of cosec x in the restricted domain. And this is discussed in the previous session. Now, what is a sine graph in the restricted domain? This is the sine graph in the restricted domain. So, this is a red color graph. This is the graph of cosec x and this is the graph of sine x. But we want here sine inverse and cosec inverse. So, I just want to find what is the arc sine graph. Same way, what is the arc cosec graph? Let us see. See, this is this red color, and this is the graph of. I shall. Right. Hide. This is this graph, this particular graph. This graph is the graph of cosec inverse x, and this blue graph is the graph of sine inverse x. So now it's clear, graph of cosec inverse x and graph of sine inverse x. Already we have discussed this graphs in the previous session when we are discussing inverse trigonometric functions and its graphs. Okay. Now our result is sine inverse 1 by x is equal to cos inverse of x, where x greater than or equal to 1. That is x greater than or equal to 1. Or x less than or equal to minus 1. It is clear here, the domain. This is the domain. The domain of cosec inverse. The domain of cosec inverse is here. You can see that it is less than minus 1, less than or equal to minus 1, and it is greater than or equal to 1. So that is the range of cosec inverse. Domain of cosec and. Now, let us see. This is the domain. Sorry, not the range. Domain. Now, let us verify the result. What was the result? Cosec inverse of x should be equal to sine inverse 1 by x. What I am going to do here? I am taking a point here, somewhere here, that is in the domain of cosec inverse, from greater than or equal to 1 or less than or equal to minus 1. I am taking a point. Okay, if I am taking a point here, I can find the corresponding point when the point, the line will be intersected in the cosec inverse graph, and when it is drawn perpendicular to y-axis, it will intersect somewhere here, and that is the value of cosec inverse of, if it is x, that is will be the value of cosec inverse of x. If it is x, and here it is cosec inverse of x. Okay, ready? Now, the line will intersect somewhere in the sine inverse x also. Okay, so if you draw perpendicular to x-axis, you will get a point at x-axis. That let us check what is that relationship. So I am doing here. You can see here. So here it is x, and it is when a line is drawn perpendicular to x-axis, and that line intersected the graph of cosecant inverse of x. And when we draw parallel to x-axis, and it will intersect at a y-axis at a particular point of y. Ready? Now that line intersects the sine inverse graph at a particular point here, C. If you draw a perpendicular line, it will intersect at a x-axis, and that will be 1 by x. So you can see here, and check it, just to check it here. You can see here, it is 2. So when x is 2, that 1 by x is 1 by 2. Now when x is 2, the corresponding point here in y-axis is this is x, so cosec inverse of x is y here. And here the point is that at y-axis it is 1 by 2. So this is 1 by x, that is 1 by 2. It is 2, so it is a cosec inverse 2. And here it is 1 by 2, so it is a cosec, and the graph is sine inverse. So this is the point sine inverse 1 by 2. So if it is x, cosec inverse of x and sine inverse 1 by x will be the same point. You can move the point anywhere in the graph of cosec inverse. You can see here. If I am extending this here, when it is moving, so it is moving, we cannot see that it is negligibly small. When it comes here, so here you can see that here only x is there. We cannot find a point in the cosec inverse graph. Why? Because the domain of cosec inverse is greater than 1. Domain of cosec inverse is greater than 1 or less than or equal to minus 1. Greater than or equal to 1 or less than or equal to minus 1. So when we take a value of x as less than 1 and greater than minus 1, we cannot have point in cosec inverse graph. So that is why we are not able to see anything here. Let us move again to the left direction. So it is coming here also, we cannot find any point here. But when it comes here, you can see here in the negative, when the value of x is less than or equal to minus 1, the same result is true here also, because if it is x and here it is intersecting at a cosec inverse graph, and we are getting the point here that is cosec inverse of x. It is x and here cosec inverse of x. If it is x, this point will be 1 by x. And here it is intersecting at sine inverse graph. So the same point we are getting that sine inverse 1 by x. So we are getting the result cosec inverse x is equal to sine inverse 1 by x whenever x greater than or equal to 1 or x less than or equal to minus 1. Now I think it is clear. Dear children, whenever we are studying this inverse trigonometric functions and trigonometric functions, we can connect it to its graphical view also. For that, GeoGebra is a very good helping tool. You can study GeoGebra by seeing the YouTube videos, GeoGebra lessons, etc. Okay? Next, we may discuss the next property. And I have proved only the one result by using GeoGebra. Okay? So the remaining I am giving to you. Now let us discuss the remaining properties. Just a minute. I want to discuss one more result using the graphical view. Here I am taking not a inverse trigonometric graph. Here I am taking trigonometrical graph and proving the same result. Okay. Not the same result, the next result. That is cos inverse 1 by x is equal to sec inverse of x when x is greater than or equal to 1 or x less than or equal to minus 1. Here I am taking not inverse trigonometrical graph, inverse trigonometrical functions graph, I am taking trigonometrical functions graph. It means I am not taking cos inverse graph, I am taking cos graph, graph of cosine function. Also, I am not taking sec inverse, graph of sec inverse, I am taking graph of sec. With that graphs, I am going to prove this result. You see here. See, this graph is the graph of sec function. Graph of sec function. Graph of sec function is defined between when x greater than or equal to 1 or x less than or equal to minus 1. And this blue graph, and this is the graph of cosine function. The restricted in the restricted domain. In the restricted domain 0 to pi. Same way, this sec graph is also defined in that interval 0 to pi, where the pi by 2 is excluded. This pi by 2 is excluded. So this is the graph of sec and cos. Now, if we take the inverse, the domain of the function become range of the inverse. The range of the function become domain of the inverse. That we know. So the domain of the particular at present case is this one. When we take the inverse, this will be the range. The range of the function become the domain for the inverse. So here I am taking the x value. In the previous case, I have taken the x value in the x-axis because I have directly taken the inverse trigonometrical graphs. Here I have taken the trigonometrical graphs, not inverse trigonometrical graph. So here I am taking x value in my axis. This is x. You can see that this is x. I shall zoom it here. So this is x. So when we draw a line perpendicular to the graph of sec, we can draw a perpendicular line and that will intersect at a x-axis. And that is the point I am taking as y because I have interchanged the domain and range. So it is x. So sec inverse of x will be here this point. Okay. Now the line is intersecting the graph of cos. And if you draw the same perpendicular, and it is getting the same value. And here if you draw a line perpendicular to x-axis, we are getting this point, and that is 1 by x. Of course, it is 1 by x. We can see that here. So if I am changing the value to 2, it is 2, and here it is 1 by 2. So it is x, this is 1 by x. This is 2, this is 1 by 2, so it's 1 by x. So it is x, so here the value, this is sec inverse of x. And here it is 1 by x, so when it is drawn parallel to x-axis, it intersects the graph of cos, so this value is cos inverse 1 by x. So sec inverse of x and cos inverse of 1 by x are same. Am I correct? Let us see the other points also. You can see that in different points. It is clear. It is clear. When it is coming here, everywhere, when it is clear. Now what happened to it is coming the left hand side. That is less than 1 and greater than minus 1. Because the domain is x greater than or equal to 1 or x less than or equal to minus 1. If I am taking a value between minus 1 and plus 1, we cannot find a point here. But because it is not in the domain of a sec inverse. So let us go back to next. Now here when it comes here, that is the x value is less than minus 1. When it is less than or equal to minus 1, the same result holds here. It is x here, so we are getting, it is a sec inverse of x. Same way, 1 by x and it is intersecting at the cosine graph, so it is cos inverse 1 by x. So we are getting the result cos inverse 1 by x is equal to sec inverse of x.